Hello, my name is Kathy Akers, and I am a graduate student of education at Morningside College. I'm currently a special education teacher at Oskaloosa High School in Oskaloosa, Iowa. My study was implementing math fact intervention will increase math performance in high school special education students. The problem statement was educational statistics are showing a decrease in math proficiency of all students in the United States. These skills include number sense, recognizing patterns, how numbers relate, math fact fluency, and automaticity. The theoretical framework of this study was based on the cognitism theory. This theory states that the mind of a learner is viewed as an information processor. Cognitivists believe people require active participation in order to learn, and it does involve long-term memory. When students have learned their facts, this is now placed in long-term memory to be recalled whenever needed. Why I chose this topic? I'm currently a high school special education math teacher. I mainly teach lower level math classes and pull out special education math classes. I often see my students struggling doing even the simplest of math problems. Quite often they're reliant on using a calculator for basic math calculations. That doesn't always work because sometimes the students lack number sense and don't realize that the answer they've even gotten on a calculator is not a reasonable answer. I'd also like to address some math anxiety that I see my students facing, and there's not much research that has been done at the secondary level in regards to fluency and automaticity. Most of those studies have been done at the elementary level. My literature review, I found a great deal of information that had the same type of vocabulary: number sense, math fact fluency and automaticity, and math anxiety. Number sense was defined as the understanding of numbers, recognizing basic patterns and how numbers relate to other numbers, and math fact fluency and automaticity. Math fact fluency and automaticity is defined as the fluency piece is defined as quickly and accurately being able to solve a math problem. Automaticity is being able to perform that calculation without having to think about them. Math anxiety is a condition where students experience a negative reaction to math activities. Studies link lack of math proficiency and automaticity to math anxiety. Math anxiety. There are a number of studies that link math performance to math anxiety. A lack of fluency and automaticity causes anxiety. Students who are more proficient display less anxiety. Math anxiety happens when students experience a negative reaction to doing math activities. Students who display math activities become unable to perform simple calculations due to that anxiety. And most math anxiety is reported is in direct correlation with math fluency. Comparing number sense to phonemic awareness. Gersten and Chard compared that number sense that when a student first learns math and becomes familiar with numbers and the meaning of those numbers, it's very similar when a student learns how to read. When that student learns how to read, they become familiar with the letters, the sounds the letters make, and thus they're able to decode the words in the same way that a student becomes familiar with numbers and their meanings and then can calculate a math problem. The instructional hierarchy set up by Herring and Eaton in 1978 is still one that's used today. They set up as acquisition is when a student first learns a skill. Fluency building or proficiency is when that student is able to perform a skill both accurately and fluently. Generalization, the student uses the learned skill and applies it to new circumstances. And then finally, the application stage. This stage, the student applies the knowledge that they have learned. Statistics show that 22% of all adults have not achieved an 8th grade level of math proficiency. 42% of 4th grade students and 30% of 8th grade students perform at or above proficiency level, according to the NAEP in 2013. A lack of math proficiency can hinder students' opportunities in the future. Those opportunities include post-secondary education, future job opportunities, along with future job earnings. With my study, I had several forms of interventions that I used: direct instruction, flashcards, technology, and timed math drills. The flashcard piece, students chose could choose whether to be interactive with their peers or whether to work independently. These students made their own flashcards as part of this project. Students can work on just the facts they are having the most difficulty with, or if they choose, they can work on all of the facts. According to Borgdahl and others in 2014 study that he performed, students increased accuracy from 20 to 90% during those interventions. Technology piece of the intervention we used where the students were able to select the facts they needed to work on most. They were not able to select the facts they needed to work on most, Students had more interaction with the computer and possibly more challenges and less boredom. And students will work on their computer and can be challenged with facts randomly. The time drills increased automaticity and recall according to Woodward in 2006, the study that he had performed. And according to Kling and Bay-Williams in 2014, they noted a different effect of students performing timed math tests as opposed to just the anxiety piece. They found that students who were frequently exposed to time tests actually performed better on those tests than students who were not. Some of the potential problems I did encounter with working on the different interventions that I used. Flashcards, students working with their partners, it sometimes did become a social time and they were distracted and not doing what they needed to do. Technology piece, as everyone knows, is always easy to get distracted or work in different windows or apps when those computers are available. And the time drills, students sometimes became overwhelmed when they're being timed and they just shut down because they felt they could not do the task at hand. The goals and objectives of my study was to determine how automaticity and fluency of the math facts affected math performance of high school special education students. My hypothesis was, by implementing math fact interventions, students would increase their math performance. Variables, my independent variable, were the interventions, which included flashcards and technology. The dependent variable was the student assessment results. My method section, my participants were high school special education students. I had a total of 23 students, 16 male, 7 female. They range in age from 14 to 18 years old. According to the NICHE in 2017, the demographics of our school district were 89.9% Caucasian, 3% Hispanic, 2.9% multiracial, 2% Asian, 1.8% African American, 0.4% Native American, and 0.1% Pacific Islanders. We have a total of 44.6% of our students qualify for free and reduced lunch. We have a total of 710 students, and 101 of those students are currently on an IEP. The materials my students used were student-made flashcards, their school-issued Chromebooks, and paper pencil assessments. The procedure was an ABA-B study. During week 1 through 3, we collected baseline data with no interventions. Weeks 4 and 5, the students used their flashcards as the intervention, and only flashcards during that time period. Weeks 6 and 7, there were no interventions used. Weeks 8 and 9, they used mentalmathtrainer.com, which is a computer application that is timed that they can practice their math skills. Weeks 10, there was no formal instruction given. The students were on spring break, but they were encouraged to practice on their own time. And week 11 was a final 5-minute assessment. The data analysis showed the baseline assessment was given at the beginning of the study. That baseline assessment included 100 randomly selected multiplication problems with a 5-minute time limit. Progress was monitored weekly with the 5-minute 100 problem assessment. The final assessment at the conclusion of the study was again 100 randomly selected multiplication problems with a 5-minute time limit. My results showed that there were no significant statistical differences in the results of the baseline scores. My baseline was the median score of 43.68, the standard deviation of 25.99. Following the first intervention stage after that treatment, Median score rose to 55.05 with a standard deviation of 59, a t-score of 2.48, and a p-score of less than 0.001. Following the initial treatment phase, which was using the flashcard, there was no loss of skills during a no treatment phase. The no treatment phase, the median score was 55.75, the standard deviation of 25.83, a t-score of negative 1.12, and a p-score of less than 0.001. There were no significant changes from the no treatment phase to the final intervention. In that final intervention was the students used the mental math trainer piece on their computers. A median score of 61.61, standard deviation of 23.20, a t-score of 2.30, and a p-score again of less than 0.001. As you can see by the chart, the light gray bars are the mean scores, the dark gray bars are the standard deviation scores. You can see that the baseline score was between 40 and 50, rising after treatment to between 50 and 60, staying very steady between that 50 and 60 mark during that no treatment phase, and then between 60 and 70 on the final treatment phase of using their student computers. The standard deviation stayed quite steady throughout the whole entire phase of the studies. Implications: I noticed that this research reinforces the idea if students know their math facts, the automaticity and fluency will increase. The use of peer helping assisted student scores as they would compete with each other to better the score than their partner. The limitations I did notice with this study, that only special education students were used in the study. There was no follow-up as to the success of the student in a math class. There was a limited amount of time that the study was performed. There was no data as to whether the student practiced outside of class, and if the students did practice outside of class, how much actual time was spent practicing. And there was no data collected to determine if being more fluent and automatic with their math facts actually improved their math performance. I would recommend to continue following the same students to collect data as to whether their math performance did improve over a longer period of time. Have a longer period of time for each intervention and rotate those back and forth. Use a more diverse group of students, including students of all abilities and not just special education students. You can see the references that I have used for this study. And I hope you enjoyed my presentation. Thank you.